Okay, this next video is about how to write one logarithmic expression that's very complicated and write it as sums and differences of simpler logarithms. And you need to express powers as factors. So how we're going to be able to do this is recall and use the properties of logarithms. And so this is log base 7 of this big fraction right here. So the first thing that I need to do is separate the fraction. I'm going to separate the numerator from the denominator using the difference property, or the quotient rule for logarithms. So this can be rewritten as log base 7 of the numerator, f to the third times the square root of n, minus log base 7 of the denominator, c to the sixth. All right. And then if I look at this is a product. This is being multiplied together, f to the third times square root of n. So I'm going to do two things in this next step. I'm going to use the product rule to separate these into two logarithmic expressions, plus I'm going to rewrite the square root of n as n to the 1/2 power, because radicals are simply fraction powers. So I'm going to write it like that. So this is going to be log base 7 of f to the third power, plus, because this is the product rule, log base 7 of n to the 1/2 power, minus log base 7 of c to the sixth power. And then the last thing I'm going to do is express the powers as factors. And so this is the power rule for logarithms. So I can throw the powers in front and they are just simply get multiplied on. I'm just going to move those to the front. So this is equivalent to 3 times log base 7 of f plus 1/2 log base 7 of n minus 6 log base 7 of c. All right. And then down here, I believe there was a question about how to convert an exponential equation into logarithmic form. And so this should say convert to logarithmic form, because you're presented with 7 to the 3x is equal to 11. So in order to write an equivalent statement, but not in exponential form, but in logarithmic form, you need to write down the word log. So begin there. Say log. In the base of the logarithm, the subscript is the same base as you see in this exponential expression. Right here, the base is 7. Base of 7 is being raised to the exponent 3x. So log base 7 is what you'll get. Then if you remember that a logarithm is always equal to an exponent, you say, what is the only exponent that I see in this expression? And it's 3x. That's the exponent. Then the argument is what's over here, 11. Very similarly, if you were given a log expression, let's just say we had the natural log of 4 is equal to m. And we had to write this logarithmic expression into exponential form. What you would do is you would recall that ln really is log base e. And you don't have to write that down, you just have to recall it. But then you say, hey, what is the base? The base, the little subscript, is e. What is the power that it's being raised to? If you remember that a logarithm is equal to a power, then the power is m, and that is equal to the argument. A logarithm is the power that the base has to be raised to in order to obtain the argument.